So, your professor just asked you to survey 200 students in your school about which ice cream flavors between chocolate, strawberry, and vanilla they prefer more. And then, after obtaining all of the necessary data, you are then tasked to interpret this data into a graph, which will then help the readers of your conducted survey understand just how the data works. Well, you may say, oh, that's easy. I could just use a pie chart or a bar graph. I mean, that could work. I could just put the three flavors together and just determine how many people, voted for a certain flavor. I mean, for instance, how many people picked chocolate? I mean, simple enough, right? Well, there is one problem that arises though. What about those students who picked both chocolate and strawberry? What about those who picked both chocolate and vanilla? And most importantly, what about those who picked all of them? And that's where the Venn diagram comes in. This is a type of illustration that uses circles, and these circles overlap or intersect together, and these are used in order to show, quote-unquote, the relationships among things or finite groups of things, according to the website Investopedia. In using a Venn diagram, you may use 2, 3, 5 circles if necessary, and these are usually used to show data that usually show comparison or the similarity between each other. Now, going back to your ice cream dilemma, you may use a circle to represent every single flavor, and then you overlap those three, which will then look like this, in order to represent those responses that picked 2 flavors or even 3. I am Winston Earl Biastokia, and I will be your professor today, alongside Mr. Ken Chung Sestasyon and Mr. Joshua Godia. We will be discussing in 3 examples how you can properly and correctly create a Venn diagram and plot out all of the correct values wherein all of the data necessary is provided.
Greeting you with a smile, my name is Ken Chung Sestasyon from A11. By now, we have already learned about the Venn diagram and its importance in real-life situations. It is now time for us to use this knowledge by solving 3 different examples with 3 sets using Venn diagram in this lecture. We'll start with our first example. In a survey of university students, 64 had taken mathematics course, 94 had taken chemistry course, 58 had taken physics course, 28 had taken mathematics and physics, 26 had taken mathematics and chemistry, 22 had taken chemistry and physics, and 14 had taken all 3 courses. Find how many had taken 1 course only. As you can see in our problem, we have 3 sets of courses: mathematics, chemistry, and physics. To get started, we will have to create the Venn diagram itself by illustrating 3 overlapping circles and a box surrounding it. Let's mark these sets by the letter M, representing those who had taken mathematics, C for those who had taken chemistry, and P for those who had taken physics. Now the problem requires us to find how many students had taken 1 course only, and this can be possible with the usage of Venn diagram. Firstly, we have 64, 94, and 58 students who have enrolled in the 3 courses. And according to the problem, 14 of those had taken all 3 courses, so we will put 14 in the center of the Venn diagram where every set overlaps. Now, to know which students had taken only 2 courses, we find the numbers stating how many students had taken 2 courses from mathematics, chemistry, and physics. The first is 28 people had taken mathematics and physics. It is now time for us to look at the Venn diagram and see where set M and P overlap. Since we already have 14 people taking both mathematics, physics, and chemistry, we will have to subtract it to 14 which equals to 14. Now let's put 14 where both M and P overlap. Next is 26 had taken mathematics and chemistry. We will do the same thing by subtracting 14 from 26, which would equal to 12, and putting it between the set M and set C. And finally, we have 22 students taking both chemistry and physics. 22 minus 14 students would equals to 8 students. Now that we have the number of students taking only 2 courses, it is now time for us to look for the amount of students who took only 1 course respectively. The first that we're gonna find is mathematics. When we look at the problem, 64 students are taking this course. To know which students are only taking this course and not the others, we're gonna have to subtract the number of students who are taking mathematics to those who are taking also the other courses. As we can see in the table, we have 14 students who are also taking mathematics and physics, 12 students taking mathematics and chemistry, and 14 students taking all of them. To get the students who only took this course, we're gonna have to subtract 64 to 14, 12, and 14. After subtracting, we get 24, which means there are only 24 students taking the mathematics course only. For chemistry, we have 94 students, 12 for both mathematics and chemistry, 8 for chemistry and physics, and 14 for all of them. Subtract them all together and we get 60, which is the number of students taking chemistry course only. And lastly, 58 students are enrolled in the physics course, 14 for physics and mathematics, 8 for physics and chemistry, and 14 for all the other courses. Subtracting would result to 22, which is the amount of students who only took this course. Now that the table is finished, the problem requires us to find how many students have taken 1 course only. As we have calculated in the table, 24 students had taken only math, 60 for chemistry, and 22 for physics only. To get how many students had taken only 1 course, we have to add them all together. 24 plus 60 plus 22 is equals to 106. And that's the amount of students who have taken only 1 course. Now for the next problem.
In example number 2 above, it is stated that in a group of students, 65 play football, 45 play hockey, 42 play cricket, 20 play football and hockey, 25 play football and cricket, 15 play hockey and cricket, and 8 play all 3 games. We need to find the total number of students in the group, assuming that each student in the group plays at least 1 game. So for the first step, we need to construct the 3-circle Venn diagram, each representing 1 game, football, hockey, and cricket, and then we label them as F, H, and C respectively. And then we input the information given to us. We start from the center, so we know that 8 students play all of the 3 games. So we could put that in a middle where all of the 3 circles overlap. Next, we input the students who play 2 sports. We could take the 20 students who play football and hockey and put it in the space where F circle overlaps the H circle. But we need to subtract the 8 students from earlier since they also play all of the 3 games, and that includes football and hockey. So the 20 minus 8 is equals to 12. Then there are 25 students who play football and cricket. So again, we subtract the 8 students first and then input the result in the space where the F circle is overlapping the C circle. So that's 25 minus 8 is equals to 17. Lastly, there are 15 students who play hockey and cricket. We subtract 8 once more, so 15 minus 8 is equals to 7. And then we input that in the space where the C and H circles overlap. Now we can look for the total of students that play each individual game. So they are the students that play only 1 game. So first is that 65 students play football, So the total number of students in the F circle must be equal to 65. But we already have 12, 8, and 17 inside the F circle, so we can add them up first and then subtract that from 65 to find out how many students only play football. So that's 65 minus 37 is equals to 28. 28 students play football only, so we input it in the F circle only. Now, let's look at the number of students that play hockey only. It should be 45, but again, we already have 12, 8, and 7 in the H circle. Just like what we did earlier, we add them up all first and then subtract again, so that's 45 minus 27, which would simplify to 18. 18 students only play hockey. Then there are 42 who play cricket. Again, we already have 17, 8, and 7, which are within the C circle. So 42 minus 32 is equals to 10. So 10 students only play cricket. Finally, we are asked to find the total number of students in the group, assuming that each student in the group plays at least one game. So the total number of students in the group, we simply add the value listed within the three circles. So that's 28 plus 12 plus 18 plus 7 plus 10 plus 17 plus 8 should be equal to 100. In conclusion, there are 100 total students in the group.
Now, let's talk about our third example. In a college, 60 students are enrolled in a chemistry class, 40 students are enrolled in a physics class, and 30 are enrolled in a biology class. 15 of these students are enrolled in both chemistry and physics classes, 10 of the students are enrolled in both physics and biology classes, and 5 of the students are enrolled in both biology and chemistry classes. None of these students enrolled at all three simultaneously. Now, we need to determine how many students are enrolled in at least one of the classes. So, like we've said and we've tackled from the previous examples, we need to look first into the number that is inside the intersection of all the three circles. However, in our case, there is no one who took all of the classes simultaneously. So, what do? Well, we just put 0 into the intersection. Simple. What about the remaining intersections, or the intersections between 2 of the 3 circles? In order to determine this, you only need to subtract the value of the intersection of the 3 circles from the initial value of the intersection between 2 of the 3 circles. However, as we said, there is no one who took all of the classes simultaneously. So, we take all of the values of the intersections of 2 of the 3 values, which is 15, 10, and 5 respectively, and write them in their intersections as is. Lastly, we need to determine how many students picked only one class. In order to solve how many did, we only need to subtract the numbers inside of all the circle's intersections from the initial number of the circle without those intersections. How? Let's give it an example. 60 students are inside the chemistry class, right? We will subtract 20, which is the sum of all of the intersections our chemistry circle is involved in. So 60 minus 20 is equal to 40. 40 students are in only the chemistry class. Another, 40 students are enrolled in a physics class, and we will subtract 25, which is the sum of all of the intersections that the chemistry circle is involved in. So 40 minus 25 is equal to 15. 15 students are enrolled only in the physics class. And lastly, 30 students are enrolled in the biology class. And we will subtract 15, which is the sum of all of the intersections our biology class is involved in. So 30 minus 15 is equal to 15. 15 students are enrolled only in the biology class. Now, it may seem that we're already done. I mean, we've already completed the Venn diagram. We've already plotted out all of the correct values in all the intersections, in all the tables, the circles, right? But then we still need to determine how many students actually enrolled in at least one of the classes. So in order to do that, we only need to add every single value inside of the Venn diagram from all the intersections and all the circles. Okay, so 40 plus 15 plus 15, which come from the students who are only in one class, plus 15 plus 10 plus 5, which come from the students who are in 2 of the 3 classes, plus 0, which come from the students who are all of the classes. And add that up, and then you get 100 students who are in at least one class. So, in summary of everything that has been explained, this is how you plot out the correct values in the Venn diagram. First, you must plot out the value given for the intersection of all the circles. Then, you must use this value to be subtracted to all the 3 remaining intersections initial values, which are the intersections between 2 of the 3 circles. Lastly, you will take the initial value of a certain circle and then subtract from it the sum of all of the circle's intersections. And repeat this until all of the circles have been properly and correctly given a value. And that is it for the applications of a Venn diagram in real-life scenarios. Good luck on your ice cream survey. Me personally, I'm more of a strawberry guy, but I like all 3 of them.